Integrated gradients is the gold standard for model explainability, but it has a hidden flaw. By integrating along a straight line in input space, it often passes through semantically meaningless regions, creating shadow artifacts where distant features falsely claim credit for your prediction. Researchers at NJIT have a fix: reveal IG. Instead of a trajectory of points, reveal IG defines a path through a space of structured probe distributions. Here's the technical shift. Rather than interpolating feature values, reveal IG progressively reveals information by moving from a broad, high-uncertainty reference distribution to a probe concentrated around the input. For images, this uses factorized Gaussian probes parameterized by mean and log variance. The path integrates gradients of the expected model response with respect to these probe parameters, evaluated via the reparameterization trick. For tabular data, where linear interpolation breaks down, reveal IG defines probes over empirical feature values. It uses a temperature-controlled similarity kernel to anneal the distribution from the empirical marginal toward the observed value. Gradients are estimated via closed-form derivatives of the categorical weights, making this black box compatible with models like XGBoost. Crucially, this maintains the completeness property. The attributions sum to the change in the model's expected output. But because the integration happens over distributions, the method naturally accommodates multi-scale probes. The early, coarse probes average responses over a broad region, diluting the influence of distant structure before the distribution concentrates. This effectively mitigates the shadow artifacts that plague input space paths. We can also view reveal IG as a continuous analog to SHAP. SHAP averages over discrete feature coalitions, which introduces axis-aligned artifacts and higher-order angular components. Reveal IG replaces that all-or-nothing reveal with a differentiable path, smoothing the output response and eliminating those structural biases. The results are compelling. On ImageNet and tabular regression, reveal IG leads in metrics that rely on attribution signs, like sensitivity N and positive evidence insertion. It distinguishes target support from suppression far better than IG or SHAP. There is a trade-off. Reveal IG is computationally heavier. It requires Monte Carlo sampling at each integration step, making it roughly 7 times slower for images and significantly more expensive for tabular models. But if you need robust, signed attributions that respect the geometry of information revelation, reveal IG is a major step forward. It proves that lifting attribution to distribution space yields cleaner, more faithful explanations.